into the description of this video, but yes, I have also written it over here so that it will be readily visible and we will be able to understand it, right? So what is the question? The question is that a tent is given to us and the tent is in the form of a right circular cylinder surmounted by a cone, right? So the tent is like this. This is right circular cylinder. Let's say this is the cylinder, okay, and it's a right circular cylinder, and this is surmounted by a cone. That means surmounted, that means on the top of it a cone is there, right, like this. So this is the shape of the tent. So there are basically two portions over here. The top is a cone and the bottom is a cylinder, right circular cylinder, right? And it's mentioned that the diameter of cylinder is 24 meter. So if the diameter of this cylinder is, let's say this is r, if r is the radius is equal to diameter divided by 2, that is 24 meter by 2, which will give you 12 meter, right? So 12 meter is the radius of the base of the cylinder, which is also the radius of the base of the cone, right? I think you can see this section is equal to this one, right? Now it's mentioned that the height of cylindrical portion is 11 meter. The height of the cylindrical portion is 11 meter. That means the height from this to this is the cylindrical portion, and this height is given to you as 11 meter, right? So 11 meter is the height of the cylindrical portion. You can see here, while the vertex of the cone is 16 meter above the ground, right? And the height from this point, let's say this point, to the top, this point, this is given to you as the vertex of the cone is, this is the vertex of the cone, this is the top of, this is called vertex of the cone is 16 meter above the ground. So the total height is 16 meter, right? So here, if you remove this 11 meter from 16, you will get the height of this cone, right? So this will be equal to 16 minus 11, that is equal to 5 meter. So for the portion of cone, this one, the height of the right circular cone is 5 meter, right? Now do one thing, to calculate the area of the canvas, that means the lateral surface area of this cone, that we need to find out. So basically there are two portions as we discussed. The first portion is cylinder and the second portion is cone, right? Now do one thing, what is the lateral surface area? The lateral surface area, or the curved surface area will give you the area of the canvas required, which is required to make it, right? Now you can see here, the lateral or curved surface area of the complete cone is basically of two portions, part 1 and part 2. Part 1 is cylinder, so that will be curved surface area of cylinder plus curved surface area of cone, right? So one is cone and one is cylinder, right? Now what we will do, we will simply measure the curved surface area of cylinder. So that is equal to 2 into pi into r into h, isn't it? This is the curved surface area of cylinder. Now the curved surface area of cone is pi r l, where l is the slant height, this one. Since we are knowing the radius, this radius is known to us, that is 12 meter, right? Since 12 meter is known to us, then this is, if this is 12, then L can be written as, by Pythagoras, root over of 12 square plus 5 square. 12 square is 144 and 5 square is 25, and 144 plus 25 will be 169, and the square root of that will give you 13. So 13 meter is the slant height. This L is 13 meter, right? This L is 13 meter. Now just put up the value, 2 into pi into r. R is 12. This radius will be same for the cylinder also and even for the cone, right? So this r equal to 12. Just put up this value in place of r, 12, and height. So height of the cylinder is 11. You can see 11, right? Plus pi in curved surface area of cone is pi rl, that is pi into 12 into 13. 13 is the slant area, slant height, or slant height of this cone. So just solve this to get the curved surface area of the cone, which will be, so from here you can see 12 pi is common, 12 pi. So bring out 12 pi outside this bracket, and inside the bracket 2 into 11, which is 22 plus 13. So this will give you 12 into pi. Pi is 22 by 7, and 22 plus 13 will be 35, right? So from 7, 35 will be cut in 5 times, and we have 12 into 22 into 5. 22 into 5 is 110, right? 110. So 12 into 110 will be equal to how much? 110 into 12. So 2 1 and then 2 1, then 132. So this will give you 132 and this 0, 1320 meter square as the curved surface area of this entire portion of this tent. 1320. So the cloth or the tarpaulin, required to make this tent should have a measurement of 1320 meter square. So in this way we have solved this question. So this is the area of cloth, or tarpaulin required to make the tent, right? So how to solve such question, students, I think you can better understand, right? For any query, you can just put up into the comment box. Hi, Yua. Yes, yes, sure, why not? I can repeat it, not a problem. Actually, let us read out the question first. The question was that this was the question, right? The question was that a tent in the form of right circular cylinder surmounted by a cone, right? Diameter of cylindrical portion is 24 meter. So here you can see diameter is 24, so radius will be 24 by 2, which will give you 12 meter as the radius of this cylindrical portion, right? And this is surmounted by a cone. That means on the cylinder, the top, you can see the conical part. The cone is present into the top. So it's mentioned that in a right circular cylinder surmounted by a cone. Now the diameter is given, so where you calculated the radius, right? Now the height of the cylindrical portion is 11 meter. So the height of the cylindrical portion is 11 meter, which is given to you, right? While and the vertex of the cone is 16 meter above the ground. So this is the vertex of the cone, the top. So this is 16 meter from ground. So if you deduct 11 meter of cylinder, you are left with 5 meter. So height of the cone will be 5 meter, right? Now you need to calculate. You need to calculate. Find the area of the canvas required for the tent, right? Now what we did, since we are knowing the radius of this conical portion, we are knowing the height of this conical portion, we can calculate this slanting height by applying the Pythagoras. And this will be equal to root over of r square plus h square. R is 12, so root over of 12 square, and h is 5, so 5 squares. This will give you root over of 169, which is 13 meter. So the slant height of this cone is measured. So to make this tent, you need to consider the curved surface area of the first part, that is the cylinder, and the curved surface area or the lateral surface area of the cone, right? So that's what we have mentioned. Lateral or curved surface area of tent, right? This is equal to curved surface area of cylinder plus curved surface area of cone, right? Because there are two portions. One is this one and another is this one, which I mentioned 1 and 2, if you can see, right? Now curved surface area of cylinder is 2 pi rh. You know the formula, 2 into pi into r into h. You are knowing the value of r, you are knowing the value of h. This is for h for cylinder, right? Since you are knowing the value of r and h, you can calculate the lateral surface area of the cylinder, and the for the cone you can calculate the lateral surface area of the cone by using the formula pi r l. Since l was not known to you, just what we did, by applying the Pythagoras, we calculated the value of l, right? Now just put up the value to get the answer, 1320 meter square. So this is the area of cloth required to make the tent, right? So students, I think if you find it useful, you can just like and subscribe. Thank you so much for watching. Bye bye, take care.